Lovely, thank you. Hey, I'm Josh. I'm a software developer working for a small startup in Farringdon called Theodo. My background in machine learning is I've done quite a few courses at university and take a particular interest in the field, not only in producing models, but in the wider impact machine learning has on society. And so one of the things I do in my job is explain complex technical ideas to traditionally non-technical people. And that's kind of what I really appreciate of what I do. And applying that to machine learning is particularly interesting given the complexity of the field. Cool, so first of all, communicating technical ideas is really difficult. If you ever try to explain how your Git workflow works to a CXO of a company, they don't really care. But trying to explain how that affects my everyday job and how that affects how fast we can deliver products at speed, then they start to actually care. So the first problem is you're very reliant on your prior experience or prior knowledge. So I can use all of my machine learning, computer science background to understand a new research paper, whereas a CEO reading about how neural networks are this new amazing technology, they have no idea or no background on understanding it. The second thing is theory or abstract ideas are really hard to follow in presentations. I think as SK suggested by his little anecdote about the M&Ms, which you never heard the answer to, by the way, where it's really hard to follow some really abstract talks. Cool, so how does this all relate to machine learning? Machine learning is like a particular instance of this problem of trying to communicate effectively to people, and has four main problems. So first off, there's still a very large growing field. We're learning new types of technologies day in, day out, with research papers coming through every month being the latest in the technology. And so it can be quite confusing. Secondly, there's a lot of muddied waters. So you get Elon Musk tweeting about intelligent singularities are going to take over the world, and it makes it really, really unhelpful for anybody not involved in machine learning, how to actually explain to them what is going on, what is it we actually do. Cool. And thirdly, it's really hard to relate to the real world. I'm talking about my deep learning model and its embeddings, and the person, they ask me, how does this actually tell me, how has it learned this? What exactly has it learned? And it's actually really hard to have any abstract, concrete ideas of like, okay, this has been learned using statistics, layers upon layers of my networks, but okay, well, how did it do that? It's really hard to explain. And then lastly, people can get quite emotional about it. So if I talk about AI taking your job, which I put up there to grab all of your attention, you start to really care about it. And talking about intelligent singularities taking over the world, it really grabs the attention of the field, but kind of in a negative way. Yeah, cool. So this is a little comic. When people ask you about machine learning, I think this is somewhat true. Some of you have probably seen this before. But it just shows that machine learning, people don't really understand it. And this is, to many people, what we do. It's black magic. They don't really understand what we're doing. We can just explain it as this bunch of stats. But it's not good enough explanation when you're trying to sell products. So people tend to push back. And it's hard to come up with an answer for what they say. Cool. So the three common types of misconceptions, at least that I found when talking to clients and friends, is first off, learnability. So this is, okay, I hear you're a machine learning expert, but can you predict this? And sometimes this is really about what is actually learnable by our systems. And it's a double-edged sword. Some people think you can do everything with machine learning or AI. But reality is, yes, you can't. It's an amazing technology, but you can't learn everything. And the second half of that is people think it's useless and can only learn previous data, and we can't predict any new futuristic results based on it. And so both of these are bad, and we kind of want to emphasize the middle part, which I'll come on to later. Cool. The second problem is kind of research. So you see Google coming out with like 95% accuracy on Google Translate, but the actual product itself is rubbish. like people have said that to me. It's like, well, you've got to understand this is research. It's very difficult to like tell people, yeah, this is the cutting edge of the field. It's got to trickle down. Cool. And the third thing is complexity. So DeepMind can solve chess. Surely you can develop some AI to solve X. And this is really, okay, right, we've got linear regression over one hand. We've got really advanced reinforcement learning on the other. Like how complex actually is your model? How complex is the problem you're solving? And this is something that people really can't quite grasp, and probably the hardest of the three problems. So the question I ask is, how can we actually help in these three areas? It's kind of a difficult question, but I hope to answer it. Cool, so first off, we'll look at learnability. The real crucial part of this is lots of people think we can learn almost anything, but in reality, we really need like clean data, as SK was saying. Like we kind of really dependent upon the data we have in most applications. I know with some things you can start with 0 day and just start teaching your model, but like if you really want a key start in business, you really need some data. Cool, and obviously the more data, the better the model. And importantly is the word clean, as I've highlighted once before. It's about the less likelihood of outliers. You want predicting even CEOs, it really helps you. And thirdly, you've got to tell people that, yeah, machine learning, it can't solve everything. It won't be able to solve all of world hunger, but we can use this tool in every day to actually give value to people's lives. Cool. So the second thing to look at is the research. How can we help people understand, okay, this is research? So the first one's really simple. So we compare it with other scientific news, such as like the CRISPR gene editing news stories. So in my view, the news articles are very similar. So the things we read about CRISPR being able to edit your genes and do all of these amazing things is highly similar to the things we read about AlphaGo, transforming, how these technologies trickle down are actually very similar, but no one ever looks at machine learning and goes, oh no, that's just research. They want it, why isn't this here now? Why isn't it here now? We want it here. And so that comparison is really crucial when I talk to people. As I say, emphasize research nature. So these are machine learning researchers, not practices. There are really great practice results, but all of the big hitting ones that grab all the headlines are almost always research based. And so emphasizing that nature is particularly important. And the true reality is we don't need research grade solutions in our everyday problems. Netflix, I'm sure you've all heard of Netflix and their Kaggle competition, where some researchers got paid £1 billion for their solution on Kaggle, but then Netflix went on to not implement it in their production system. And so sometimes you don't want 99.9% accuracy. Sometimes even something like 60% is enough. So whilst this research is amazing and cutting edge, sometimes it's not what we need on the product level. I think that's quite interesting. Cool. Thirdly, complexity. How can we kind of help people understand this? So the complexity of machine learning is really, really dependent upon your problem space. And so getting someone to define what they're trying to solve with machine learning is really important to tackle how complex their models will be. And actually building up from ground zero saying, okay, have you tried doing any form of statistics on your data to begin with? It's a common approach that we use to build models, but maybe it should be a common approach to say how we actually deal with clients who want to enhance their understanding of their data. They kind of need that. And that can lead towards, okay, what kind of complexity, what models do we need to solve this problem? As I say, build up ideas. So when you're explaining machine learning to people, you kind of want to build up from base level. And so an example is using linear regression to build up all the way to deep learning. If most people in businesses have done economic degrees, they'll understand what linear regression is. And so it's about taking something that somebody already knows and building it up into this complex idea. Is commonly how to actually relate the, not truth, but accuracy of description of what machine learning is in this great field. And again, we have tons and tons of open source models. And these aren't the complex things, really. You can take any model, any clean data set, plug them together and start hitting some results. And so actually, whilst your problem may seem really, really complex, it's never going, well, commonly never going to need cutting edge research grade models. You can pull something off GitHub, use that, and really start tackling like AI, machine learning, bringing it into your business. So it's much easier than people think. Cool. This is something else. So there's a lot of media disinformation, basically. When people talk about their fear of machine learning, commonly people say, oh, but I don't want a machine looking at my data. It makes no sense to me, because if you start looking at proprietary software, you see that you get software with an unknown algorithm based in statistics created by humans. And the funny contrast is machine learning is an unknown algorithm based in statistics, but just created by computation. There really is no difference to the end user. But when you talk about a computer deciding whether or not you can get a loan, suddenly people get really angry, and it's like, what's a computer doing, making decisions for me? But I like, proprietary learning will be less accurate than machine learning in most cases. So actually, the computer making a decision is better for you. So I think it's kind of funny. Cool. It's only been a brief talk, but I think I want to highlight the really impact of communicating machine learning effectively to people in business and to like the general population. We're very privileged in that we have a deeper understanding and exactly what is available with this amazing technology. But it's really crucial to communicate this in an effective way and truthful way. And I appreciate it's hard to do that with, yet like people tweeting. Elon Musk's tweeting about AI is extremely unhelpful, and yeah, it's a personal pet peeve. Anyway, so we can't avoid all clickbait, but if we communicate our knowledge effectively, then we can share this amazing technology with everybody. And that's the one key thing. We want to share this technology, which I'm grateful for H2O for hosting this thing, and Microsoft for giving the building. Cool. So that's been my talk. Thank you all. I'm Josh. If you want to find out more about business savvy developers who really care about communicating their ideas effectively, feel free to contact me and Theodo with that email. Cool, thank you. Any questions? There's a couple around.
Hey, thanks for the talk. So I guess from the headlines you're talking about, some of the most striking results from machine learning come from these kind of closed systems like chess and Go and so on. I mean, in the business context that you've seen, where have you seen some of the better kind of results on the day-to-day?
So quite limited in terms of the business that I use. We focus mainly not in machine learning. Machine learning is kind of a side interest of mine. So I've had quite limited exposure to the actual business implications. What I've learned is from talking to clients about it. So for example, we work with an insurance company and they were talking about using machine learning for their models. But again, unsure of how to apply it, whether or not it's going to be impactful. Is the statistics we already use important enough? Yeah.
Hi, my name is Marek. So you started with this nice picture of like big data pile, right? And you're saying it just goes there and mix it up more. I'm quite new. I'm trying the unpacking journey for 12 months now, and I'm trying to get more involved in this. And is there any way to stop just mixing it up and maybe find the features correlation, create another layers on top of it, or to feed it? I don't know.
So looking, you can. I think the first step is looking at your data set. You can learn simple patterns in your data set to begin with. But if you're starting to explore what your model's learning, what I've done when I've taught models is run a few example cases. Like you can represent your embeddings, so your weights on your network, and see which features are particularly not advantageous, but indicative of a certain result. That's the best way I've looked back at it. But if you're looking at really deep learning models, then it's really complex to do that. The only thing I've seen is Lime, which can, you've heard of it. Cool.
So you talked a lot about your clients. I'm just wondering, so when you compare the clients who kind of get it versus those who don't get it at all or have some prejudice or misconceptions, which features differentiate those, the former from the latter?
So I worked with a company that needed some NLP, and they understood the technology, but when we were working with them, it really wasn't ready to cope. Like, it wasn't accurate enough for them at production level, which is unfortunate. But things are looking, it's a client we'd like to get back in touch with, but they understood it, but knew that it wasn't applicable for them, which is quite frustrating, but something they should revisit. Did I answer your question? I'm not sure I did.
Maybe if you generalize, so, if you look at some of the clients that you, from your point of view, were more adept at implementing this and compare them, against those who were really lost, do you think there are any particular features, like on a corporate level, on a management level, that help some companies get ahead of others?
I think it's having a general awareness of what's possible. So you really need to understand that it's not some research, you don't need to have research grade cutting applications. You need to actually try using some data, using some models, seeing if you can start picking up results slowly. Using that kind of MVP approach and applying that to machine learning is what I think is actually the more valuable thing to be doing.
Thank you.
No problem. Cool, thank you.